Okay, and we are live. Hello, everyone, and welcome to today's workshop. Just a quick sound check. Please, can I ask you to give me a thumbs up if you can hear me well? Let's see.
And the same with me. If people can hear me out there too, that'd be really great.
Yeah. So good morning, Nitesh. Okay, can I take it you can hear us? Let's see. I don't see any. Okay, so I see some thumbs up. I think we can start. sound check for Aaron as well. I take it as a yes. So let's start. Okay, yes.
That's good.
Okay, hi everyone, welcome. Welcome to today's workshop. That's actually week 3 in the summer series focused about learning and using Cassandra to build your own applications, which is the topic of today. So maybe we are seeing your slides, Aaron, so I would give it to you.
All right,
okay.
yeah. Well, welcome to being able to to learn about building out applications in Java and Python and Cassandra. This is actually going to be kind of a first where we're going to try and help everyone through with more than one language at a time here. So the exercises can be attempted in either Java or Python once we get to that point. So yeah. We've got Stefano on the Python side, and I'll be running the Java side. So hopefully things will go really smoothly, and we'll see how this all works out. So y'all get to be a part of trying something new today. So there we go.
It's very interactive. We'll see. Okay. So.
All right. Well, Stefano, maybe you should introduce yourself.
Sure.
Huh?
So I'm Stefano. I'm Stefano actually, but everyone calls me Stefano. I live in Italy. I'm a developer advocate at DataStax, particularly interested in distributed systems and of course Apache Cassandra, which is my favorite database ever. I usually wrote in Python and a bit of JavaScript, and I used to be a physicist. Please, these are my contacts, and feel free to join me to reach me on my social networks.
Now, did I see that you have a PhD in theoretical physics?
Yes, that's true.
That's pretty seriously cool. Yeah. We should start calling you Dr. Stefano,
please.
right?
Please, no. That's good. That's okay.
All right. Well, anyway, I'm Aaron. I live in Minnesota, so in the United States, but I'm also a developer advocate. I also do try to focus on like the database reliability engineering side of things as well, but I'm also a bit of an author. I've written a couple of books on distributed databases. 7 NoSQL databases in a week was one I worked on, as well as mastering Apache Cassandra 3.x. I've spent a few years as an engineering lead in the real world, and I spent about 5 years as the NoSQL engineering lead for Target, working on like large scale distributed systems, mainly Cassandra. And I also spend a bit of time on Stack Overflow. If you asked a question on about Cassandra and Stack Overflow, odds are that I've probably helped you out. So yeah, that's a little bit about me.
Great.
So of course, in addition to Stefano and I, there's a whole team of people behind us here at DataStax and developer relations, helping us build all this content out and bring everything forward. So hey, just thank you to everyone, and you'll notice that some of them are probably online in the chat and on Discord. So yeah, in other words, it's more than just Stefano and I.
Yeah. It's a pretty big effort to try to deliver you the best experience, the best workshop. So yeah, so maybe we can. Okay, I'm having some strange. Okay, that's all good.
All right.
Okay.
So yeah, here's our agenda. Right now we're doing just a quick introduction. We'll talk a little bit about microservices and why Cassandra is a good fit for building out with microservices. We'll focus a little bit more on like the REST API access or aspect, I should say, of microservices. And then we'll build up towards our sensor IoT application, as well as a REST API along with that application. And from there, we'll kind of go into the quiz and the homework and maybe what's next. So here we go.
Cool. Okay. Will you just go over this slide quickly? Because
Oh,
I'm
of course,
sure
yeah.
our friends are waiting to do a bit of interactive quiz or questions.
Right, right. Yeah, sorry, Stefan, I wasn't sure if you wanted to take this one,
Okay,
but
yeah,
yeah.
sure. Okay, so that's real quick. Practical advice to what to do with us today. So first, you are watching us live on YouTube, unless you're watching us recorded, because the same, you can watch us also later recorded at the same link. But basically, we are going live. We are live on YouTube right now. So, and that's one thing. In case anything goes wrong with YouTube, which very rarely might happen, we will give you a link to reach us on Twitch, which is our fallback channel. That's one thing, but of course we want this experience to be as interactive as possible. So besides the lots of hands-on you will do later, running code and doing stuff with us, you can also ask us questions, and that's something you can do on the YouTube chat here on the side of the stream, and also on Discord. On Discord, maybe I can have our friendly Nightbot give you the link to join us on Discord if you want. That should come out in the YouTube chat right now. Yes, there it is. I personally today have been locked out of Discord for some reason, but I have to retrieve my password and try again. So maybe you will not see me today on Discord, but tomorrow you will. But I'm sure there are a few other folks from
Discord was being tricky with me today too. I also had to re-log in, so maybe there's something bigger going on.
Yeah, but I think they unrolled some password policy change right today. I don't know exactly. But the most important thing for interactivity is that there will be a quiz at the end of today's workshop, and you will be given a chance to win some swag. And this quiz we will do with menti.com. You will see later, but this Menti, we will use Menti also to ask you a couple of questions before we start, just to get to know you better, the kind of audience we have. Yeah, so that's it. And but that's not the end of the story, because next slide, please.
Yep, there you go.
Because so what are the tools we are going to use today? A cool thing is that the whole workshop will never leave your browser, basically. So you will do everything with your browser. Namely, we will use a database, which is ASTRA-DB. We will tell you more about that later. And it's a database as a service, so you can use it as a web service. Easily, you can log in, you can register, create your database, and start using it within 2 minutes or so after creating it. And that's all for free, and doesn't require anything else than a web browser. Not only that, but we will use Gitpod. Gitpod is a very cool IDE, basically running on top of a remote machine, a container that is created for you somewhere in the cloud, somewhere else, and you will just access it through the browser. You will see it. It's just an IDE built after VS Code, basically, and again, nothing to install. And of course, the main material comes from GitHub, because we prepared a repository with everything, all the instructions to also work on today's material in a standalone way. But of course, today we will go through it together. And there you will find code, instructions, and also the slide deck we are using today. So that's not the end of the story, because in the next slide, you will see there is something for you also to do. Okay, no, this is, so we have an academy, which is, okay, that the academy is a full online learning website that will teach you everything you need to know about Apache Cassandra and surrounding technologies. You will find links later elsewhere. We have also DataStax/dev website with a bunch of interactive courses and other useful learning material. And GitHub, I mentioned that already. And maybe in the next slide, there should be an important points, because we also, Aaron, can you jump to next slide, please?
Oh, sure. There you go.
Because once we are done today with the practice and everything, you will be able to gain a badge of attendance, a verified badge of attendance. But that's not just something you get because you were here today. You have to show that you did some work. So we have a little homework for you that you will be able to do after staying with us today. And then once you do the homework, there is a Google form. You go there, you submit your homework, and we will grade it in a few days, and you will be receiving your verified badge. And with this badge, you will be able to brag about and feel better than anyone else, basically.
It is kind of cool to see everyone, you know, kind of post those and show those on LinkedIn. So and that's cool.
Yeah, I want to add that if you are the collector type, we have maybe 20-something badges for different courses, for different workshops, and there are a few folks who really are collecting them all, and that's cool. So because we run a lot of workshops, and maybe I can ask Nightbot to workshops. Is that right? Remember, so we have a whole agenda workshops and that we run usually every week or so. So if you're interested, you can learn a lot about several technologies, not only Cassandra, but a bit of everything. Of course, Cassandra is the main focus, and today is the third week of a 3-week series focused about Cassandra, Apache Cassandra. So learning how it works, learning how to write the proper data model with it were the first 2 weeks, and today it's the time to write a small application using that. Yeah, so.
All right. So we'll also, you know, as a part of, you know, going through Menti, we'll give out some swag as well to the winners. So we'll have a, you know, a little bit of a quiz at the end where we'll, you know, have some questions about, you know, the material that we covered. And, you know, if you're in the top 3, I think you should get a swag package. So.
Yes, that's right, top 3. So now I will switch to my screen because it's time to start playing with Menti. So
excellent.
I will just ask you 2 questions, I think 2, just to warm up and to have you log in to have you connect to Menti. So there should be, yes. So you please open a new tab, or even better, maybe from your phone. You should go to menti.com and enter the code you see here, or maybe the code that you also see here. So I'll make these, yes. So you can use the QR code, you can use the code you see on screen or in the YouTube chat. So go to menti.com, enter this code. And then, okay, so I see people are starting to join. That's very good. These are just questions to find out exactly who you are. No, just to know the kind of audience we have, and maybe to try and adapt a bit the content to your preferences. Of course, please keep this connection to Menti open, because at the end of the workshop, there will be the real quiz. And those will be timed questions. You have to answer fast and correct. And if you are among the fastest and the correctest, you will be winning some nice swag. So I see, maybe we wait until a couple of more people join. Let's see.
Yeah, how many do we have in right now?
I think we have half of our audience is in. So, okay, maybe we can start.
All right.
Okay, so, okay. So these are just questions to get to know you a bit. And first question, did you attend a previous episode or the 2 previous episodes of this series? Cassandra Fundamentals, Data Modeling, which is the second, or maybe you are just new to this series. I see an even split, more or less. So, okay, yeah, very much an even split. That's interesting. Okay, so well, if you attended the previous one, then you probably know what Cassandra is. You know how to work with it on the CQL console. You probably know a bit about how to properly do the data modeling part, which is a very delicate and a very important part when you design your application. But I see for many people out there, this is their first encounter with Cassandra. So please, Aaron, let us try to make it as easy as possible for everyone.
No problem.
These episodes are more or less standalone, and we will guide everyone quickly through the whole business of creating the ASTRA DB account and everything. So don't worry, it's not a problem. Okay. Of course, if this is your first, then in today's repository, you will find links to the previous episodes, which you might find interesting, and probably they will help you clear out everything in your mind. Okay, so what is your language, your preferred language for today? As Aaron said, we are offering basically the same set of exercises, both in Java and Python. We will try to be a bit of a quantum instructor, so to speak. Let's exactly see how much time we will have to do that, to do the quantum part. I see Python beats Java 2-1.
Yeah,
that's very much
there's
in line with the recent
Python
trends.
folks here. Wow.
Yes. That's good.
Yeah.
Okay. Okay. Ignore one bot. Well, Rax, I'm sure you know both, so that's not to be ignored. Hi, Rax, by the way. So you see there is Rax in the chat who is going to help us maybe at some point. Very good. Okay, so more Python than Java, and a fair share of newcomers today. Okay, thank you. I can switch back to the slides, Aaron, if that's okay for you. And please keep this connection to Menti open for later. Okay. I think you can take it from here.
Well, hey, we're going to spend, oh, sorry, you good, Stefano?
Yeah, sure. Go ahead.
Oh, all right. We're going to spend a little bit of time just briefly covering what was the focus of the previous two sessions. And the first one being an introduction to Apache Cassandra. So, for those of you who haven't used it before, Apache Cassandra is a distributed database. Its distributed nature allows it to handle a lot of big data related tasks quite easily. It's really good with both read and write performance. Although that does tend to bear in a little bit with how you build your data model, as Stefano alluded to. It's linearly scalable as well, so that if you have a 6-node cluster and you're getting 10,000 operations a second, well, if you double that to a 12-node cluster, you should now get 20,000 operations a second. That's really what that linear scalability means. It's highly available, which means it's peer-to-peer. There's no single point of failure. So you can lose an entire node or maybe even a couple and still be able to serve all of your data. So that's really the kind of the cool thing with Cassandra there. Right along with that is its abilities around like self-healing and automation. Where if you have a node down and there's a lot of writes coming in, you have one node that'll kind of take on that responsibility and save those writes up as hints for when that machine which failed comes back. So there's a lot of things built into the fact that, really, when you look at large scale hardware, something's always in a state of failure, and that's what Cassandra is designed to handle. And then probably my favorite feature of Cassandra is how it's geographically aware, where you can build in logical or physical data centers in a out in Cassandra, and it'll know how to work with those and how to distribute your data, as well as how to serve data specifically to your customers in different regions. The whole idea there is that you know, when you have a worldwide application and maybe you have users on a mobile app, you know, you don't want users on their phone in London making a data call all the way over to a data center in San Francisco and then waiting for that to come all the way back. You want them to be served by data that's local to them. So that's really where that geographical distribution comes into play. And then, of course, too, you know, Cassandra is, you know, platform agnostic. You can run it in any cloud that you want, and vendor independent as well. It's an open source project. You know, there's no one company that controls it. So, so yeah, that's Cassandra in a nutshell. We're not going to be working a whole lot with Cassandra's, you know, internals or things like that today. But it's good to have an understanding of that underlying data storage architecture before we get too deep.
Yeah.
All right. So, session number 2 was about data modeling specifically. You know, we've mentioned so far that the data model is really key to getting optimal performance out of a Cassandra database cluster. And really that approach to building a good data model, you know, it kind of starts with that whole, you know, conceptual data model or building an ER diagram like can be done with a relational database as well as, you know, understanding like your workflow patterns and how things are going to flow, you know, with the application and how it's going to work. And really what that does is it lends itself to that second point here of applying a query first approach. And that's ultimately how that logical data model gets built. And then as we start to look at that model and start to put it through its paces and use it, we realize that you know, there are optimizations that can be made that really result in refining that down into the physical model. And you know, there are some simple principles to make that work. Just that, you know, remember that your data is weather for Sheboygan. That's funny, Rags. You know, quick side note about Sheboygan, Wisconsin is it's actually supposed to be the best freshwater surfing area in the United States. I'm not a surfer, but you know, I have friends who did, but yeah, there's a beach on the south side of Sheboygan where the waves from Lake Michigan really come in pretty good, and it's quite popular with surfers actually. So I digress. But
I didn't
anyway.
know that. At all. Cool.
So yeah, so data is both replicated and partitioned. I mean, we'll get into a little more about what that means as well. But essentially, you know, when you take that query first modeling approach, just remember that you want to store together what you want to retrieve together. That's the main way to think about it. And as well as when you think about writing your data, you know, as how it's going to be queried, you want to make sure that those partitions aren't growing unbound, and that they're not going to get too big, or that the same ones aren't going to get queried too often, because that's going to lead to like hotspots in the cluster. So it's really about coming up with a data query and distribution strategy at the same time.
Yeah. One cannot understate the importance of this part.
No, for sure.
But the good news is that today the data model has been already done for you. So even if you are new to the series today, you will then be able to catch up later and just stay with us and look at the development part, the application writing part. So that's good.
And I see in the chat, Katie Fox says she's supposed to do a polar bear plunge in Lake Michigan on New Year's Day. I've done that. I was with a group that did that every year in Milwaukee, and we used to go on January 1st go jump in Lake Michigan. Yeah, that was a riot.
Cool.
Anyway, so here's what Stefano and I are going to be talking about today. Is application development with Cassandra as the backend or as the data tier. Specifically, we're going to focus on like what's shown here is like the backend or the application tier. So we'll be taking you through writing, Java and Python code that uses the Cassandra drivers to pull data back from, Cassandra, or in this case, ASTRA, which is, DataStax's Cassandra as a service database, which of course, if you haven't used it before, you can totally use it for free. So there are no worries around that.
Yeah.
All right. And of course, as we've kind of been highlighting this whole way through, you get to take your pick on whichever language you want to do the exercises in. We've actually written out, code for this workshop in both. And yeah, once we get out to Gitpod for the exercises portion, you'll get to choose Java or Python, or you can go back and do both. Or if you're really fast, you can do both at the same time. I'm not that fast, but maybe Stefano is, but yeah.
You could, especially because the API will run on the 2 different local ports, so they will not interfere with each other. So you technically can keep them running at once.
Oh, that's a great point. Yeah.
Just
all right.
Just for fun, of course.
All right. So yeah, we've talked about the badge, but if you complete today's workshop and the homework that comes with it, you'll be able to have this badge sent to you and be able to do some bragging out on LinkedIn. Hey, I got my APIs and microservices badge from DataStax developers. So that's what we're shooting for today. All right. So hey, we've done a whole bunch of introduction. Let's go on to talking about microservices and maybe why they work so well with Cassandra. So one thing to remember when you're working with microservices is kind of the history and kind of how we got to this point. If you look back in like the 90s and earlier, we really had like monolithic application systems. Mainframes had been in use for decades, even at that point. And really it was, the UI, the services layer, the data layer, they were all combined into, sometimes into one machine. Yeah. And, we kind of progressed through the years. I remember too, the earlier 2000s were very, very like client server, multi-tiered architecture approach. Where you have your front end, your back end, your data layer. The mid early 2000s, like 2005, really kind of saw that service oriented architecture approach start to take shape. Raise your hand out there if you've ever worked with SOAP. Yeah, that was for the time it was good, but it was just one of those things where just there are parts of my brain that are damaged from doing so much XML, but I digress. But anyway, today, we have the microservices approach, which really offers more isolation in terms of the different layers and kind of how they interact with each other. All right. So again, for microservices specifically, we're looking at Martin Fowler's book of building microservices. Oh, wait a minute. That's Sam Newman's book. Well, anyway, I digress. But remember, the whole idea is that the services are modeled around the domain. It's a culture of automation. I mean, you really do want to try to get away from a lot of like manual steps, especially when you might have a service layer that has, dozens of services on it, working with and running DevOps on all of them can be quite tedious. So it's important to consider that automation aspect. But the idea is that, to keep these individual services like as independent as possible and isolated from the other services as much as possible too. And it's really about, kind of how I went back to how Cassandra is really designed, to support environments where there are hardware failures. And that's really what microservices kind of addresses as well, is that, you might have pieces of the stack that can fail, but that shouldn't take down the entire service layer just because of one simple failure like that. So that really is the point that we're driving at here. All right. So of course, taking a microservice architecture approach does have its advantages. You've got the definite reduced cost in terms of like, scaling and design, reduced risk. Again, I mentioned that that whole resistance to failure aspect of that type of design. Increase in release speed. And the cool thing about this is that you can actually release like individual parts of the service layer instead of having, to release like do like a monolithic service release. So it really does kind of help you be more agile on your feet in terms of being able to deploy changes. And of course, it helps to enable visibility as well. Where you have new opportunities out there for security and monitoring, and everything that comes along with observability in that sense as well. Now, the disadvantage, though, is that a microservices approach can be a little on the complex side. Where we mentioned security visibility as a plus. Well, security does get a little more complex because now you do have multiple endpoints where you do kind of have to worry about these things. Oh, we lost my audio for a bit, really? Stefano, can you hear me okay?
Yes, I can.
Okay. Oh, well, that's
didn't
weird.
see anything weird. But...
Yeah. I just saw a note from...
Yeah. Okay, fine.
Yeah. Oh, fine.
Okay. Should be all good.
Okay, cool. Thank you, Greg.
Hi, Greg. Okay, cool. So maybe
excellent. Oh, Katie heard me too. Outstanding. Okay. All right. Maybe it's just rags. I don't know. It's important to note too that taking a microservices approach does involve like a cultural change as well. It's one of those things that you really do have to have everyone on your team on board with to be successful with. So that's important to note too. And a bigger run footprint as well. Especially when you start getting into like the serverless microservices approach. Those of you who work in infrastructure know that the serverless is kind of a misnomer. It still does run on a server. It still does run on many servers. It's just how many and where they are has been kind of abstracted away from the developer. So yeah, if you're working on the infra side, that can lead to some challenges. All right. So we've talked about how microservices should be, isolated, and they shouldn't share anything. And, really that means that you should have a database for each service. So it comes down to the question of, do you do that? Does anyone do that? And if not, why? Hey, Stefano, I think this is a really great point to make. It definitely, highlights the differences between, what theory is and what reality is. You know what I mean?
Yeah. So deploying a whole different data infrastructure database, a different database for each service is sometimes too much. It's something that not all company can afford, unless they have an infinite operations team behind. So you find compromises, right?
Right, for sure. And sometimes too, in terms of Cassandra, you could even go the route of giving each service its own key space. I mean, that does offer a certain amount of isolation as well when you do things that way. I can tell you though from practical experience, working at when I was at Target, that is what we did. When we had a team who was building out a new application or a new service layer, they really did get their own Cassandra cluster. But again, that's because you look at Target Corporation, they're gigantic, and they really do have the resources that can support that, like a dedicated NoSQL team, dedicated folks on like the service level, at the storage level, even out at the cloud level too.
Yeah.
So it can be, it really does depend on, how many resources you have available. And I mean, that's for sure. That's for sure.
Yeah, but of course, as you can also consider a compromise such as sharing the same database infrastructure between services, but each service going to a completely separate cell in this database or key space in our case, for example. But in that case, if you still want to keep the illusion of complete the actual setup of complete the coupling, then you need a database that is not much relying on relations and triggers and not a relational database, in other words. So that's, I think many of our attendees are starting to see where we are going, Aaron.
Yep. I think we've made the point.
Yeah.
All right. So real quick, getting back to one of the core principles of Cassandra, and specifically any database which is non-relational. You know how when you work with a relational database, like Oracle or Postgres, MySQL, MariaDB, etc. There's this concept of ACID, of having all of your transactions be atomic and consistent and isolated and durable. In the NoSQL distributed non-relational world, that's not always read never possible. So there's a different approach which non-relational distributed databases tend to take, and that we have this concept of base instead of ACID, where it's like things are basically available with soft state eventual consistency. And really what that means is that, when you build any large scale distributed system, there are compromises to be made. And one of those compromises is in ensuring strong consistency in place of, sacrificing strong consistency for performance and for availability. For always being able to give a result set instead of an error message. That's really what base is about. So yeah, that's and that, again, that kind of lends itself, to when you look at CAP theorem, where you have consistency, high availability, and partition tolerance. Well, Cassandra ends up being more of an AP system, which really does allow for idempotent type of operations, and can definitely keep things going in the sense of again, when you have those failures, you'll always get a response back, or you'll always be able to perform a write. So that's really the whole idea behind it. All right, so continuing down that path, the idea is that our data layer is like loosely coupled, where we have data that's replicated out in multiple nodes. We have load balancing that happens, but that actually happens at the driver's side. The Cassandra drivers themselves actually have what's called a load balancing policy, where it figures out query routing on the client side, so it kind of knows which nodes ahead of time it has to talk to. It also does things like health checks on the driver's side. And I already did mention a little bit about that hinted handoff aspect of Cassandra database as well too, where if there's a node down that's responsible for a certain range or partition of data, and you have a write that happens, it makes sure that data doesn't get lost, even though the node that's supposed to host it is down. So essentially, it creates it as hints on other nodes, and that's how things eventually get reconciled once it comes back up. But again, we want to make sure that we're going with that shared nothing idea, on a per key space level or per table level, even for profile with your role-based access controls. So yeah, you'll have Shelly asked a good question. How does it know which node to hit? Well, actually what it does is when you build your table, and we'll show this in a little bit, but it takes the partition key and actually hashes that into a token, and each node is responsible for a range of tokens. So based on that token, that hash token value, the driver knows which node has to be contacted for the data. So that's a really great question.
Yeah. So not only is the driver aware of which node has the data you need, but even if you hit any other node, that would internally be able to coordinate the query within the cluster and get your data back.
That's right.
That's a double layer of insurance for you.
All right. I kind of jumped to the first hands-on slide a little too early there.
That's great. It's okay.
But,
I think it's good time to move to the first part of the practice, which is creating or resuming your database. So let me start by giving you a link in the chat. Okay, so here is the first quantum split of today, because we have seen at least 1/3 of you are new to Cassandra, new to AstraDB. So we will assume you don't even have any AstraDB instance yet ready to use later. So the rest of you have already created it in the previous weeks. So I will try to show you both how you will do from here. So first, if you are new to Astra, you should go to the link I posted and register for it. And that's just, you can sign in with GitHub or Google or username password, and it's a very short sign up process, completely free, nothing asked. Just sign in, and once you get in, you will be able to create your database to start using it in a couple of minutes. Everyone else, that is, those of you who already created your database in the previous weeks, stay with me, because now I'm going to show my screen for, yes. So this is the actually this is the sign in page of AstraDB, which is a version of, basically, it is a database offered as a service in the cloud, and it's built on Cassandra, but it's, let's say, Cassandra minus all of the operations and maintenance and management burden. So let me log in. Of course, I already do have an account. That should go. Okay. So whether you already do have an account and logged in, or you just signed up, I'm going a bit slow for whoever wants to sign up now. This is your dashboard when you are logged in. So there are many things that can happen here. Stay with me. First, let's say you created your database last week to play with data modeling. Then probably your database, which is going to be called workshops, unless you did something strange, your database would show up as this little brown dot, like my DSDB here, and you will see it is hibernated. You see here, maybe I think you can see, or maybe I can switch to my fancy demo screen with our cells made a bit smaller to leave room for, you know, the interesting stuff, let's say. So your database might be hibernated, and you will also get this kind of notice. Then if you click this button, resume database, or maybe you can also click it here by so you go to the dashboard for your database and you can resume database. If you click here, in a couple of minutes, your database will be rehydrated, resumed, and ready to be used. That's something, of course, that only happens for the free tier, because it's a free tier. Anyway, the other option is that your database is green already, which means active, as it is the case. As is the case here for my other database, like this one here, my company. You see active databases too. My company is active. That means it's ready to be used from right now. But if you just arrived and you just created your Astra account, then what you have to do is to create a database. And that you can do, maybe I'll show it again very quickly. That you can do with this button, create database, or even this create serverless database here. So if you go to create a database, and this is only for, of course, for those who haven't created a database in previous weeks, you can create it by just calling it workshops, by giving the key space name of sensor data, if I'm not mistaken, but I'm going to check because it's a good excuse to show you the README in the repo, where all these instructions are listed. In particular, we are in the prerequisites, of course. So you need the database, you need to have followed the previous weeks, let's say. You need to have created your ASTRA instance. This is the button to go and create it in case you haven't. Database name, workshops, and key space, sensor data. Aaron mentioned that, but a key space is more than just a grouping of tables. But for us today, it is a logical group where we store all tables, related tables together. Let's say for the whole set of tables needed by an application, for example. Okay, so database name, key space name. Then select the provider and region. I suggest to stick with Google Cloud because in the free tier, that's the one most. Okay.
Oh, yeah. Sorry, Stefano. I think I got ahead of you a little bit there.
Yes, yes, sure, because I'm showing your screen.
I wasn't sure if that was intentional or
Sorry.
not, but
no,
yeah,
that wasn't.
yeah,
But that's good.
I did my best to follow along with you.
You did great. Thank you. Yes. Okay, so are you going to continue then? And I thank you for that. Or
oh no, that's cool. That's cool.
okay. So so do I switch to mine again? Well, at this point, you can continue creating the database because you did, which is, I am grateful to you indeed because I messed up with creating the database. So, okay.
Oh, that's all right. Oh, hey, mine's active now.
Yes.
Excellent.
So while Aaron created his database, in the meantime, he gets this nice token information, which is hidden, but actually can be copied. And I suggest, so in any case, I'm going to create mine as well. So region, stick with Google Cloud and stay with any region that is available now without the lock icon, the padlock icon. Okay, so maybe I switch to mine so I can then go on.
Yeah,
sorry. Yeah,
that's a good idea.
So we are back to my screen and I'm creating my database as well. Looks like, yes. So this is being created, and while it is provisioned, as Aaron was showing, you see there is on the right, I see this pending token generated, and in the meantime, here I can see my token. Now you wonder what is a token? Of course, this is a very important piece of information because it will later be used as connection credentials because this database is in the cloud. And of course, to be able to connect to it, you need some authentication methods. And this is the token. You see the token is made by 3 parts. In particular, the first 2 are client ID and client secret. I'm going to copy it to my reliable notepad here. For, let's say, in real life, you will probably save it to somewhere safe, but I'm just keeping it here. And in the meantime, the database is going to be finalized. Okay, so either because you already had the database and maybe you had to wake it up, or because you created the database, let's say you all have your database there waiting for you, active. Go to database here. And you have your token, your credentials ready to be used here or somewhere. You downloaded a CSV or maybe a JSON, anything. Okay. Just in case you already have a workshop database, but you don't have a key space called sensor data, don't forget there is this add key space button here on the right. So you can add a key space, sensor data, and then you call save, and that would be then created in a matter of seconds. Okay, so let's head back to the repo, and maybe let's give everyone a little time to make sure everyone is up and running with, ready with a database and the token information. Can you give me a thumbs up in the chat if you have an active database and the token information, please?
Yeah, and I hope Eunice made it through okay. She indicated that it was asking her to pay, so I asked her to double check that she was picking GCP. I'm pretty sure GCP should
yeah.
Still getting stuck on database created. I have to pay.
Yeah,
Really?
So for the free tier, GCP has a bunch of regions where you can just create a database and go ahead.
Yeah, that's a good point. It might be dependent on the region.
I'm sure that Belgium in Europe, for example, is can be accessed immediately, no questions asked. Yes, so I see a question how to get the token, and that's also something I would like to show. So let me go back to AstraDB again. Let's say you created your database last week or 1 minute ago, and for some reason you don't have the token. No problem. You can create a new token. And to do that, the best way is you go to your main Astra dashboard like this. You see your database is listed here. Active databases, now it's 3. For you, probably it's going to be 1, but no problem. You see these workshops. This is the one we just created. You go to the far right, and there is this nice dot button, which contains generate a token. Then, if you click to generate a token, we can create manually, let's say, a token. Because every time you create a new database, it comes with a specific token made for you, ready to be used. But in any case, you lost it or whatever, or you need a token with different permissions, you can generate a token like this. And to do that, for today, we need to select the token with the powers of database administrator here. You see, database admin. Choose this role here and generate the token. And that's it. So to anyone who hasn't a token yet, this is the way to go. You start from the database and generate the token to it. Now the token is displayed in a different way. You see client ID, client secret, and token proper. Just if you click on this notepad icon, you can copy it, and just for completeness, I will do that. Of course, you can also download as a file here, as a CSV in this case, but that's not something I need today. But anyway, this is, let's call it second token. Why not? So client ID, client secret, and token proper, let's say. Anyway, I will use the first one, no big difference. Okay, so this is how you get the token in all cases. The GitHub repo link, yes, that should come in. Oh yeah, sorry, Rax, I didn't see you put it already. Okay, so by this point, if you have your database and your token ready to use, we are done with the prerequisite part. We just need to start the IDE I was bragging about.
I think we need the secure bundle too.
Yes.
Right.
So okay. So first, let's get the secure bundle. Good point.
Yeah.
Okay. Yeah. That's because that will be shown later. But in order to
sorry.
let me go back to my main Astra dashboard. For the drivers to connect to your database, you don't only need user and password, which is basically secret ID and token ID and token secret. But you also need something called a secure bundle, which is a small zip file containing routing information and certificates to make it easier to just reach the right whatever inside the AstraDB and go through the proper proxy system and reach exactly your database. And to do that, I'll go to my workshops database here. So now I am in the dashboard of my workshops database. You can click to this connect tab here below workshops. So there are a few tabs, and now I'm going to the Connect tab here, which contains a bunch of possible explanations and instructions to connect to the database in several, very many ways. Now we go to connect using a driver here, and you can choose any language. For example, Python. If you click to this Python, you will see a big blue button, download bundle here. And you can download the bundle. That's about a 12 kilobyte file, which I just downloaded, and I can keep it there for later. Now, this is a zip file, but you don't need to open it. You just keep it as a zip file, and then we will use it later as it is. It's a task for the drivers to open and look what's inside, okay? So let me show that again, because that's very important. How to get the bundle, the zip file, because we will need it in a second. Go to your database, workshops, click on it here. Then locate this Connect tab here, because we are going to connect, so it makes sense. In particular, there is this listing on the left. Connect using a driver is our target, and you choose any language here, Node, whatever. Then finally, there is a blue download bundle button here, and if you click on it, you will be able to connect, to download this bundle, okay? And that's the whole thing. Now, there's a question about Golang, which I leave to Aaron in the chat, maybe.
Yeah, I saw that too. We are actually working on a Go SDK, but we don't have an official one for it's available through ASTRA right now. I can tell you there is a Go CQL driver out there, which is community maintained, but it works really, really well. And Viraj asks in chat, which language are we following for this session? You can actually pick either Java or Python. Either one. We have exercises for both. Oh, yep. And yeah. Stefano, you saw that one. Yeah. You beat me to it.
Okay. So it's important that we, at this point, all of you have a database, a token, and this file, the zip file, the bundle, ready to use. Because now you are all going to create your own IDE, your own service to start running the code. And that's going to happen in a container offered to you by Gitpod. To do that, please head to the README, which I post again because it's never too much. Please open the README on GitHub here and locate this step 1. You see there is this big button open in Gitpod. Now, I suggest you to right-click and open a new tab or whatever, just to keep the README also available. So if you open this link in new tab, something magic happens. So probably you have to authenticate with GitHub. Let me show you what I have to do. So you have to authorize Gitpod to access your GitHub profile. That's just a way to log in. And now what's happening? And that's happening for all of you. A container is started somewhere in the cloud. On top of it, which is basically a Linux box ready for you to use. And on top of it, an online IDE is started. And this is it. You see? Now, what I have in front of me, and maybe I can try making it a bit bigger. What I have in front of me, and you should probably also have, is an IDE in the browser. Not only that, but the repository has been cloned for you. You see, there is the full repository here, and there will be code that we are going to inspect and we are going to run. How is this IDE structured? On the left, we have file browser. You see this vertical box here. On the top, we have file editor, which is also useful for previewing, but I'm going to close as much as I can. So this will be my file editor. And the bottom part is, in this case, there is a debug console, which I want to make collapsed. I have two separate consoles. One says ready to rock, and one says ready to curl. This is just our choice, and that's because when we will be later running a shell, sorry, an API, we are going to also send some requests to it. But for the moment, let me make the curl shell very small and let me focus on the main console here. So you see it's a Linux box and you can run commands as usual. Okay, so the next step is we have to give the secrets to this machine, because later we are going to connect to Cassandra, to AstraDB from here. So let me go and locate the bundle I just downloaded. That should be here. So
I'm busy doing the same, trying to find mine.
yeah, that's tricky. You have to open whatever your file browser in your local machine is.
Mm-hmm.
You pick this bundle, the zip file that you just downloaded, and look, I'm just dropping it here on the left. And that's it. So ignore the fact that Gitpod editor is trying to open the zip, don't worry. But the point is that here my file has been uploaded to this remote editor, this remote IDE. You see, Secure Connect Workshop zip. That's one thing. As instructed by the README, that's not the end of it, because we also have to provide the secrets, the token information. And to do that, you see, you see that there is a .env file here, which is basically a template to create my actual .env. Okay, so this is all explained here. Now we have to copy this template into an actual .env file. Let me do that here. And then it's a command that I can run in this console, cp env sample into the file .env, and then we ask the editor to open it. And there we go. Now, we have four variables defined here. The first two are client ID and client secret, the ones found in the token. So these are going to work as credentials to authenticate with the database, with your own AstraDB. So this will be different for you, of course. So you put client ID and client secret here and here, and that's it. Then AstraDB secure bundle path. That's probably good already as it is, unless you gave the database a funny name. But just to check, you might just want to run this ls command and see if the output matches. So
that's a great idea, because that specific problem has bit me at least twice while I've been testing this scenario.
maybe with another database or whatever strange things.
Yep.
So that should be correct, but just in case, you can make sure. But anyway, this should be the absolute path to your bundle file. And then the key space, you probably have nothing to do, because unless you went creative with naming your key space. So this is now my .env file, and that's all good. Now an important step is simply to source it. So source.env. Okay, now the environment variables have been injected, and the any application later will be able to pick them up and use them to connect to the database. Great. Now, I'm sure every one of you who went through the previous workshops, the one about data modeling in particular, they already have everything, tables, data in the tables, everything for the example we are going to use today. But let's say, well, some of you are new, and maybe some of you messed up, or you played with different columns or whatever. So I'll show you how you reset your database and your tables to have the right setup to start running the applications. So one thing is, we can quickly jump to the SQL console here. So I'm again in the ASTRA dashboard for my database workshops. I can jump to the SQL console, which is one of the tabs. And that's a very handy tool, because it's, again, in the browser, but it's a console using the SQL language that makes it possible to just run commands onto the database using the SQL Cassandra query language. So again, all instructions should be here. And it's very simple, actually. First, I have to use sensor data. Then I have to desk tables. well, in my case, what tables are there? I just created the whole database, so this is empty. But let's say you have some tables that you want to delete. You should do a drop table name, whatever. Of course, in my case, that won't work. But that's how you reset everything if you want to get aligned and do and work with the correct structure, let's say. Now, of course, today is not about SQL too much. It's not about modeling the data. So all we ask you is, if you want to just reset your database, click on this Initialize SQL. That's a big file with a bunch of SQL instructions. You can blindly copy everything of this file and simply paste it here and watch the show. Magically, a lot of things happen. Actually, well, I'm going to quickly show you what happens. We have tables now, and tables contain data.
Hey, there we go. Yeah.
Everything. So this is just in case, you know, a rescue button to align, to get everyone aligned and get ready to do today's exercises. So let me go back to the README in the repo. Okay, we are done with the setup. So database created, secrets and bundle ready to use. Then we open Gitpod because that's a useful playground to run stuff. That's going to be our IDE. And file for the secrets to be later picked up by the application. And file for the secrets, and then everything goes to sourced, ready to be used as an environment variables. And just for the sake of it, we have gone to the SQL console. We have reset everything, deleted, dropped all tables in case they were funny or whatever, if you feel like doing that. And then just by running this giant script into the SQL console, you get the right table with the right shape and everything is populated. So ready to go with the next steps. Okay. I think I can stop here and jump back to you, Aaron, for the part that comes, if that's okay.
Yeah, I think that's good. You know, I know that that someone was asking if we could go over the SQL console steps again.
Okay.
But really the simple part there is that you know, if you're on your database and you click on the Connect tab, or sorry, the SQL tab, it'll take you to that SQL shell interface. And then I posted a link to that initialized SQL file. Oh, VJ got it working. Excellent. If you open up that file like Stefano did, that gives you the table structure and the inserts for the data to get everything in your key space, you know, on the right.
So of course,
right set. So
we are not going into the details of why and how you create the tables like they are. This would be bringing us too far because today we want to see code running. That is the subject of previous week. So you are strongly encouraged to just stay with us and later go and have a look at week 2 to have a better idea of how you do what you do and why. Otherwise, we will not finish today on time, I think.
That's a good point, Stefano. Yeah. We maybe we'll speed up just a little bit here.
Yeah.
All right. I don't want to go too fast. I don't want to lose anyone, but let's shift gears back to you know, the REST API, because we are going to build out a REST API today. That is the goal. All right. So, you know, when we're talking about APIs and you know, and building them into a service layer, there are several that out there that you can use. You know, one is gRPC, which is Google's remote procedure call. That actually is gaining some popularity. There's more and more folks using it today. You can actually use that with Cassandra as well. But yeah, basically it's there's a little bit to set up in terms of, like, you know, the protobuf files and whatever. But it is very, very high performing. So gRPC is something to you know, to consider. On the other hand, if you're more concerned with like a convenient way to access and abstract a number of different data sources, GraphQL is another very popular way to to pull your data back. And basically, GraphQL is it's just simple. The steps here are basically just like you describe your data and you just ask it to give you what you need, and it comes back. And the cool thing is that it's not overly verbose, and that you can have like precise payloads. So GraphQL is actually pretty cool.
Yeah.
And then of course, we're talking about REST, which is what we're going to work on today. And essentially, RESTful services are ones that are built out with their URLs in a certain pattern, and there are different like base commands that are operations that are with each endpoint, like doing a get or a post or a put, and also listed here are like patch and delete, although those are not some of the more common ones, but that's okay. And essentially what you're doing is, it's a more like I almost want to say like an idiomatic way of working with working with your data, and hitting specific endpoints and parameterizing your data in terms of what you're giving it and what you're getting back. So REST is what we're going to go with today. Now, there are some positives for REST, of course, and that you're kind of you're decoupling that client and server. So you're getting your schema on a read. You're not really concerned with hard schema requirements. There's also the life cycle of a REST API. That if you update it and you already have like tenants or clients or customers out there that are expecting that endpoint to behave and be structured in a certain way, you can just create a new version of it and have your newer tenants actually hit that version number 2 or version 3 or whatever it is you happen to be on. There's a lot of tooling out there for REST as well. Oh, Shelly, no, we're not going to use Stargate today, but Stargate is pretty seriously cool. That that is our way to one of the ways we have to interface with ASTRA. But that's a great question though. Stargate is awesome. Yeah. Anyway, so the thing about REST though is that the payloads do get a little verbose. There's no like natural discoverability. That's something you have to kind of build in if you're using like OpenAPI to generate a Swagger spec. It can be tough with like command-like functions. Doesn't lend itself easily to that, but on the flip side of that, it's a CRUD superstar. So if you're working with a database and you're doing a lot of those create, read, update, delete type of operations, REST is really, really good for that, as I hope you'll see. Well as the like OLTP based mutation operations as well. It's good for public web APIs, and it really lends itself toward the microservice principle of like having a focused business scope for what you're trying to do, making it easy to build that in. So. All right.
REST is not going away anytime soon, let's say, to sum it up.
No, it's not. Not at all. So now that we've talked a little about REST, let's go into our sensor application that we're going to build. So again, I kind of mentioned that before, that this is what it looks like when you're conceptualizing building out an application on top of Cassandra or AstraDB, where you have your front end, you have your back end, you have your database layer. Today our UI is going to be the command line, but that's okay, because we're really going to build out a lot of cool things into the back end in the application tier for sure. So yeah, again, as we've mentioned, you'll get to choose your own adventure here, so to speak. You'll get to pick, hey, I want to go down the Java path, or hey, it looks like most of you are going to want to go down the Python path. So that's how we're going to structure this going forward. All right, but as far as our drivers go, we actually have a lot out there, and yes, I know it's been brought to our attention that yeah, we don't have an official Go driver, but like I said, the Go CQL driver is out there in the community, and it's pretty good. I've used it quite a bit, but likewise though, we at DataStax we offer drivers for Cassandra for C, C++, C Sharp, Ruby. There's a ODBC one. There's a Node.js one, and of course, Python and Java. Like I said too, plenty of like community driven drivers as well. Like I know there's one out there for Rust as well. If you're one of the people who's trying to do more with Rust, there's definitely a driver out there for that as well. But again, the drivers really what they do is they just help you provide that basic connectivity, some basic functionality around like health checks, helping you authorize and authenticate, helping you reconnect when you need to. And you also get things like building out your CQL statements. If you want, you can use like a query builder or ORM. Many of these drivers do offer that. Yeah, and of course they also offer things like paging. Like if you're pulling back a really big data set, it'll try to do it a quote unquote page at a time, so as not to overwhelm the cluster. All right. So depending on what language you're using, I know that we're also showing dependency managers like NuGet and npm here for JavaScript and C Sharp. But with what we've built today, you'll be using Maven on the Java side for pulling down the Java driver, as well as pip on the Python side for accomplishing the same thing. Now the thing is that when you build out your connection, oh, look at that! VJ got it to connect already. Outstanding.
Yes, he won.
That's great. Oh, not VJ, Viraj. That's right. My bad. Anyway, but as far as the slide goes, when you're connecting to a cluster, if it's Apache Cassandra, you really only need the IP of one node, and your driver will do discovery on the rest. Yeah, I know. Gitpod is an IDE. Cool. Super cool. I agree. It's awesome. Yeah. Anyway. Yeah. But like the slide says, it's a good idea to offer a few endpoints just to have that resilience in case that one node you want to connect to happens to be down. But yeah, really you only need one contact point or one IP, and it'll find the rest of the cluster.
Yeah, that's because in Cassandra, all nodes constantly speak to each other and keep each other updated on the health status and who's there, thanks to a gossip mechanism. So you don't need to give more than a handful of IPs for the machines, and the rest is self-discovered. That's cool.
Yep, that's right. All right. So as far as connecting goes, I know that we've had some questions around oh hey, are we connecting here? And I remember I responded to someone in the chat saying, oh no, we're just getting the environment ready. But this is actually how you would connect up in all four of these languages. And I even though we're only working with Java and Python today, I love the fact that we're showing how to do this in 4 different languages here, because it allows you to see just how similar it is in all 4 of these. Yeah. It really is a very, very similar approach. The methods and kind of in some cases here the fluent way to build these things out is very, very similar across all. But where basically you're giving it an endpoint, you're telling it what key space you want, your local data center name, and then your credentials, and that's it. All right. So now with ASTRA, it's a little bit different. The cool thing is that that secure bundle that Stefano had you download will go ahead and take care of things like the endpoint that you're going to connect on, as well as the SSL certificates to connect to your specific ASTRA cluster. So that's definitely all a part of that. And then he also mentioned too about how the client ID is the username and how the client secret is the password. And that's really how you're going to talk to use those to talk to ASTRA today, based on those entries that are in that that .env file. All right. So again, here's that that connection code from an ASTRA standpoint, where you're seeing that the path to the secure bundle is specified, and then also passing along like that key space name, and then the username and password, which are really that that client ID and secret.
I see more and more enthusiasm by Viraj for Gitpod, who self-discovers open ports. The way there is an interesting question about how are we parallelizing the queries. I think that means with the drivers. Well, today we are going to see a basic usage, but these drivers have synchronous, asynchronous, reactive ways to use, and they also, to some extent, they can be internally handling parallelization, if I'm not mistaken. So, plus you can write your own layer to parallelize queries, depending on your data model and whether it pays off or not, of course.
Right, right. This slide brings up a good point about how you handle the connection out to your cluster. And this goes for both ASTRA and Cassandra, and that you want that you want that connection object, or that session object, to be created once and then used for the entire life of the application, and then destroyed at the end when you're done. So that's actually very, very important. If you're, depending on which language you're using, you'll want to create that session object as like a singleton. Again, making sure it only gets created just once. And it's not something that, it's not like you have a connection and you're opening it, running a query, and then killing it and disposing of it, and then doing that process all over again. You'll want that connection to stay up for the life of the application. So that's important to note. Okay, so now we're going to get a little bit into the CQL queries here. Up here I've got some code in both Python and Java that essentially takes a CQL select and is trying to pull data back from that that sensors by network table for a specific network. And you'll notice we're doing this, and we're kind of building the strings together here. And this is just a quick way you can use that session.execute in both cases to go ahead and put together like just a quick query to go ahead and run. And for one of our examples today, we actually are going to do this. But the real way that Shelly, that's a great question. Yes, network is the primary key.
You should ask for which table. So, sorry, in the slide.
In the slide, yeah, for that sensors by network.
Yes, it is network.
Yep. Anyway, I was just going to say we're looking at the Python example here, but really, instead of doing like a string builder for your CQL queries, you really should use prepared statements. And there are some advantages that go with doing that for sure. One thing that and of course, here's the kind of the same approach, but doing that with Java as well. And the main difference between Python and Java here, and yes, session should be a singleton. Anyway, the main difference I just wanted to point out between Python and Java is just that there's that extra step of creating a bound statement here that to bind the variables to the prepared statement before you execute it. Although there are ways to shorten this up too. So, like I said, there's advantages to using prepared statements. Essentially, you're saving Cassandra from having to parse your query every single time. So it's like you parse once and it gets stored in the prepared statement cache, and you can run it many times. Essentially, what that does is it saves multiple network trips back and forth for like, metadata around, the query and the result set and some other types of things. These prepared statements will allow you to do like client-side type validation, to make sure that your parameters, which are integers, are getting sent as integers, and your parameters that are getting sent as like strings are actually getting sent as strings. And the cool thing too is that, statements that bind specifically on partition keys can actually compute their own routing, which is important to, running things in a high performance manner, in that, your driver will know exactly which node to send the query to. All right. With that, we are on hands-on part number 2 here.
That's great. So I'll jump to my screen, and this time I'll try to monitor. Yes, there we go. Okay, so part 2. This is where we run code. So get ready. Okay, so I see there are a few questions, I think, on the Java side of handling sessions, which I will just leave to Aaron, maybe in the chat.
Yeah.
So, okay, so let's see what is on the README, because you are now at the bottom of the README if you are following with me, and then you have to choose your path, either Python or Java. Now, I will start with Python because that's what looks like to be the majority of attendees of you. So I will start with Python, and I will try to explain the important parts of what's going on in light of what Aaron just showed of the drivers. But even you, Java folks, pay attention, because most of the concepts are the same, and the code is almost a one-to-one, line-by-line translation. That's exactly as Aaron remarked when looking at the session creation. The usage is very similar, especially as long as we run the very first simple exercises. So let me go to the Python part of the README, and we will start by running small applications, standalone command line applications. First, you remember last thing we did was to source the env file. Now, I hope you can see, maybe I can try to make it a bit bigger, but too much, then it scrambles up the interface. So we'll see. Okay, so first thing, cd Python. What is here? In the Python directory of the repo, there are a bunch of Python files. But there is also a requirement files. So if you run pip install -r requirements, which is standard practice for Python folks, this is just needed to install, well, let's look at the file, why not? This is needed to install very important Cassandra driver in its latest version, and also a bunch of other things that we will need later to run the API, because to run the API, ta-da, we will use FastAPI. But at the moment, the only thing we are using is Cassandra driver. Okay, so we have the requirements, we have installed the dependencies, and we can just theoretically run things. But before doing that, I want to quickly show, since you are fresh of what Aaron said, I want to quickly show the most important file in this Python directory, which is db connection. This is a utility module that just offers the function getSession. This getSession takes care of reading the environment variables, using them, you see, using them in the cluster creation part, which just follows what Aaron showed in the slides. And from the cluster, so it creates a cluster from the Cassandra drivers. From the cluster, it creates a session, which is a cluster connected and specifying also the key space, and then just returns it. So this getSession will be used elsewhere in the code to just have a session ready, open, and speaking to your AstraDB or your Cassandra in other cases. Now the trick. What Aaron said is you should not just keep creating sessions here and there, because they they are heavy objects, they consume resources, and creating a session involves an initial negotiation. That means a bit of time. So that's why we have a rudimentary form of a singleton here. So I have a global cache, and the first time get session is created, this is actually created. And the next time, we will just return a cached session. So we ensure that there will be only one session for the whole duration of the whole process, which is the good thing to do. And then we also register a shutdown hook here to make sure to cleanly close the resource. That's more or less everything in DB connection. And by the way, this DB connection will be used by the standalone command line scripts and the API alike, because that's the same thing. Okay, so much for showing you how DB session works, and let's use it. And the very first exercise will be running this X00 connectivity. Let's first run it, because why not? Then we look at how it is done. Python X00 connectivity. Okay, so it worked. You see? Okay, to run it, you just Python name of the script. And what does this do? This just, let's look at the code now. This is just getting the session, running a simple SQL query from, there's a system table containing names such as the name of the cluster and the data center and so on. Indeed, this is what we are reading with a select from this system local special table. So rows is a result set, which is the kind of the data type returned by running session.execute, as Aaron was showing in the slide. So we just give a string containing a valid SQL command. We call session execute, and then with the one method, you can just select the first row returned by this query, which is the only one there should be, the only one we are interested in now. So if this exists, then we just access the various columns of this row by the standard member name syntax. And this is what you are seeing printed, right? So connected to cluster CNDB at data center, blah, blah, blah. Now, it's interesting that you see the session is created and closed as instructed in the DB connection singleton kind of implementation. That will be clearer when the API runs. But if you got to see this message, then your connection works. You are speaking to your database and you're getting data back with a simple query. That's great, isn't it? Okay.
Yes, it is.
Yes, it is. Okay, has anyone been able to run the same up to seeing this result? Can you give me some thumbs up if you managed to see these output or something similar, maybe with a different data center probably, because I'm in Europe. Is anyone? Okay, yes, same thing with Java. Yes, 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 I'm very happy.
Excellent.
Okay, so it works. And then you have been using the DataStax driver to speak to Cassandra. That's great, or to AstraDB more properly. File not found, that's strange. That's strange. Maybe something with the bundle, because that looks like a temporary directory the driver unzips the bundle to. Aaron, what do you think?
Yeah,
looks like
that's a, huh.
Okay. Yeah, that sounds like a bundle unzip thing, because there's a point where the bundle creates a temporary directory, and maybe some weird permission issue with your Gitpod for some reason might be the trick. Or no, I think I know what might have been. Maybe your bundle is an incomplete zip file for some reason. You might want to try re-downloading the bundle and re-uploading it to the same location on Gitpod, especially if it's less than 12 kilobytes. Then it might mean that the bundle is somehow incomplete for some reason. Maybe you downloaded it partially or whatever. That might be, but otherwise we will come to that later. Maybe you can reach us on Discord. Okay, so let me move to the next exercise. So this is an exercise, still a Python script, standalone, but again, I'm tempted to first run it, and I will do it. So Python x01 query Q3. So this is running Q3 query, which is the one to get all sensors in a given network. And you see, this is actually what happens. It will open the session, run a query, and print the results one by one. So it gets back 3 lines because of the data we have populated the tables with. And it will just print all details of these 3 rows. Now, I didn't spend time showing you the data modeling example all of these scripts are based on. Well, very quickly, it is a network of sensors collecting temperature measurements, and this link is in the GitHub repo. Of course, this was subject of the data modeling, but the important thing is that there are queries. In particular, Q3 is tell me all sensors in a given network. And as Shelley remarked, you need the network name as a partition key to get the sensor in that particular network. So let's try giving it another. So Python VolcanoNet. VolcanoNet should be one of the networks that exist, and this has 2 sensors. Great, so it all works. Now, the code does something not so different from the previous one. It gets the session, it decides what is the network to use, and then you see it is just running session execute, and then a big string with a SQL query. Look, here there is a placeholder, and then the second argument you execute is a tuple with just this one argument matching the placeholder here. And then if you iterate over rows, you are able to read its columns, its fields, sensor, latitude, longitude, including characteristics, which if you look at the data model is a column of type map from text to text. So it's a dictionary itself. You can browse it as a dictionary and inspect every individual property like accuracy, high, sensitivity, medium. This is all contained into here, characteristics. And this happens row by row. But you know what? This is not the ideal way to run such a statement, because you just heard about prepared statements. This is not. Every time this is executed, this is parsed again, and a bunch of metadata about types and schema have to be exchanged back and forth to the database. That's why we have X1B, which does the same, but in a prepared statement way. So just to compare, first, let me run it, but don't expect any different outcome. B, Q3, no, 0, 1B, sorry. 0, 1B, okay. Same output, but done the right way. So you see, this is Q3 statement is a prepare statement. Again, session prepare will get a statement with a question mark for the placeholder. That's just there, ready to be executed as many times as you want. Indeed, this is one of those times. Session execute, I pass the prepare statement and then just the value of the placeholder. So I'm binding the network name to this question mark, and this is executed faster, and it can be executed multiple times with minimal overhead. The rest is the same as the basic execution. So that's it for the standalone scripts. Do we have time to do the Java? I'm afraid.
I don't think so.
Okay.
Yeah.
Okay, so
yeah, if anyone has questions on Java, feel free to drop them in the chat, and I'll help you out, or send them along put them in Discord as well too, and we can
just to show. If you go to the Java path, it's really the same. There is a different way to, well, you have to build, compile, and run, and you should be getting the very same results. And the code is very similar, except all 3 scripts are packed into a single main class for simplicity, and it's just a matter of providing a different command line parameter to choose what action to take.
Yeah, that's right.
Yes, so maybe I'll suspend here and give it back to you for the last part before we come back to running the actual API.
Yeah, this should be pretty quick too, actually.
I think so. There you go.
All right. So now let's take a look at our sensor application and give it the ability to serve out queries in a RESTful manner, or serve out RESTful endpoints, I should say. So essentially, the way that we're going to accomplish that, as far as you know, like which language goes, you know, obviously we're using the there's no shutdown connection. I thought there was. It should be in like oh, it's in like what, like the finalize method, I think. I'd have to look. But anyway. But there should be a shutdown in there. Anyway, I digress. If you're you know, running the Java side, we'll be using Spring Boot MVC here. As well as the drivers on the back end. Oh, and it looks like Nitesh got his bundle figured out, so that's good. That's good to hear.
Great.
And then you know, as well on for Python on the back end, what we're going to use is FastAPI, as well as the Python driver to kind of build all this out here. All right, so you know, the places to kind of see how we handle a lot of this. You know, if you look at the Python code, you know, you'll notice that Stefano has everything laid out in that API.py, and then the DB connection py is where, you know, the connection to ASTRA happens. And then likewise, I have the sensor network Spring app in Java defined as the Spring Boot controller. And then it uses the Cassandra connection class. And actually, I think I have an ASTRA connection that also like extends out that Cassandra connection object as well. But essentially, it sits on top of the Java drivers and performs the same thing. I think the next slide here. Oh, yeah, okay. So we have our sensor API, and really we're just going to have two simple endpoints. Where we want to retrieve sensor data by network, or where we want to retrieve specific measurements for a sensor by date. And the way that we've architected this is the first one of retrieving sensor data by network is going to be a simple get of just doing a get on sensors by network, and then passing along that network as a parameter. For the next one though, measurements by sensor date, we're using it as a post, and as you can see underneath here, you know, we have the sensor ID and the date passed along as like the body payload essentially. And of course, that brings up the question, you know, when you have folks who work with you know, REST APIs a lot, you know, it'll bring up this discussion of what's the RESTful way to do it, you know, and why would getting data be a post? Well, basically, we wanted to be able to show how to go ahead and pull data back by sending that body payload along. So that's really the idea behind this. And you know, as we discussed this, Stefano brought up a great point of like, well, what if you have like multiple parameters for your query, and you know that URL could get a little long. So sometimes being able to send that as a body payload can be advantageous.
Which would rule out doing a get, because get has no well accepted notion of body. So that's a bit of a trick. And this is not straying off the path of RESTfulness, because RESTful is a broad specification. It doesn't mean get to get data necessarily, but this is
not necessarily.
Even though this point itself is a bit controversial, there are various levels of acceptance of the REST specification. So there's a bit of philosophy going on here, but let's go back to Earth and run some code. Yeah, it's a funny discussion. You hear it now. You hear it now and then. What is the RESTful way? This is not RESTful. This is anyway. Okay. So all these will be clearer as I'm showing you the code doing that. So can I jump? Yes.
Yep.
Okay.
I think you can take it over for our last hands-on
Great.
here.
Get
Yeah.
ready. Third part of the hands-on. Now we are going to run the API. In the meantime, I found out how to make the more room for the code. So by collapsing the file editor, that's great, because now I'm going to need both consoles here. One is in the Python and it's in the previous one. And now the first thing to do is very simple. I was in the Java, so let me jump back to the Python pathway, and in particular to the sensor API part. So how do you start a FastAPI application? That's the way. So we have also installed UVCorn, which is basically a proxy layer implementing the so-called ASGI specification for the modern asynchronous way of handling Python web applications. I will just run it. Sorry. UVCorn API :app should do the trick. And then that's it. So the API is running on port 8000. And as someone was very happy to see earlier, notice that Gitpod is immediately picking that up and showing you, what do you want to do with this port now? In this case, we don't want to do much because we're going to just issue a couple of requests. But Gitpod is very friendly to us in this case. Okay, so let's say the API is running. Let me first run a query. So I'm going to use curl. Of course, you might want to do whatever you prefer. You might want to do Postman, whatever. I like curl. So I'm just going to do a get to the endpoint sensors by network. And the second part of the query of the URL is the network name, VolcanoNet in this case. And then I just use JQ for fancier formatting. So let me run these in the second console while the API is running. And if you pay attention, try to see how long it takes this time. Go. Okay, so it took, say, half a second or so. And you see on the right side console, I get my nice results, nicely packaged as a JSON. So there are two different sensors in the VolcanoNet network with these and that properties, all nice, all good, and that's it. Now, if you look at on the left, you notice that the session has been created, a statement has been prepared, a statement Q3, and then that's it. So now let me run this again. The same get. You see, that was very much quicker. And that's mostly because the session is reused, but also the statement is reused. So even the prepared statement was cached on the first time and just reused again. And this can be used as many times as you want with minimal overhead. That's one of the main advantages of prepared statements, besides the schema checking and everything.
Okay. Well, that's a great experiment, yeah.
Yeah, it takes a bit to create the session in particular. It's mostly the session. Okay, right. So in this case of a get, you see the last part of the URL was the parameter that the function corresponding to the endpoint would have to take and use. Let's do the other endpoint that is implemented, measurement by sensor date. This is, as Aaron said, this is a post. Indeed, we are passing a payload, which is sensor ID, date, a string. So again, this is something that I'm going to just take and paste here on the right. Okay, so I get my results. You see there are a few measurements corresponding to sensor S1001. Very good. And in this case, you see the session has been reused, but the statement Q4 has been prepared now because it was a new statement. So if I do it again, the statement Q4, the prepared statement was in the cache already, and so on. So you get how it works. Now, let's have a look at the API code. A couple of minutes. Okay, so, we made it so that API is a single module, which is not very dramatic, but it would complicate things too much. In a real application, you probably would have only this API code part in this module and the rest placed into several submodules, helpers, and so on. But that's of course not the goal for today. Let's start with the FastAPI part. This is the core of the FastAPI code, and well, every endpoint is routed to a function, a Python function, and you see how the parameter network is declared in the routing through this decorator. This network is the same as this network, which is the argument to the Python function getSensor. In this way, this is all done for us, of course, and when this function gets executed upon a request, the value of network will be whatever, VolcanoNet, ForestNet, whatever. And the rest is really nothing new. So I have a prepare statement for Q3, and I use that to session execute, as you know already, and then I just repackage the results in a way that is ready to be returned to the requester. Something very similar happens for the post, but in this case, instead of having, so how do the parameters, the payload of the post get parsed? That's something very cool of FastAPI, in my opinion, because you just have to define a pydantic data class, which is here, this base model. This extends a pydantic base model. You just define the shape of the payload you want. So this sensor date string query is going to be the data type for these params. And if things match, then everything will work automatically, and you will be able to just access the body fields like param sensor, params date, and so on. The other cool thing, let me just do one thing just to make the API get annoyed. Let me pass a wrong field name, sensor X. Unprocessable entity, and I get back a self-explanatory error message. That's very cool. And that's all done for us. You don't have to write a single line of code to get that. Now, back to us. Every one of these endpoints will need the DB session, right? And that's also where FastAPI shines, in my opinion, because it has a sophisticated dependency system. So you see, FastAPI offers the depends object, which can be just a parameter in your endpoint functions. And with this syntax, we will just have session available in any one of the endpoints ready to be used. And this getDB session is basically the one you saw in the DB connection, except it is just wrapped to be a generator instead of just a straight function. But that's it. Well, that was a quick tour through FastAPI. I have to say I love this framework, and I think it's the best out there at the moment. So, well, maybe something very similar happens in the Java case, thanks to the magic of Spring Boot and the Spring Data Cassandra in particular. So maybe I can just show very quickly. Here is, okay, so the ASTRA Connect part.
Yeah.
Let's look at the API mostly. So after defining a bunch of data classes, basically, which represent input and output data types, the most important part is the Spring Boot application itself, which is a class that is made into a REST controller and a Spring Boot application with the proper annotations. And again, that's something very similar to what you saw in the Python case. So there are annotations to attach methods to endpoints. Again, network becomes network with this path variable annotation. And something similar happens to parse, to have the request body for a post automatically parsed into an object that offers its members with getters and setters, well, getters in particular. That's not much different. And also the way prepare statements are cached and used, and also the session is mostly similar, except this is a class, so it can leverage having members. So these are just easier to handle, but the gist is the same in the case of the Java API. Oh, that was quick. And Yeah, I think we got somehow to the end almost on time.
Yeah, just about. Just about.
So there's something that is missing in this in today's workshop. Let's see if some of you can remind us what it is. Maybe there is a quiz to be played. Who knows? Okay, let's go to the quiz. Let's see. Okay, so if you can spare this last 5 minutes, you might be winning. So let me go back to the quiz, and I'll give you the code again. So thank you everyone for having enjoyed that. And now it's time for the quiz. So please join us if you haven't already. To participate in quiz, you need to open a browser tab or your phone and point it to either this QR code or go to menti.com and use the number you see on screen or in the chat, 63543365. Just a remark, in case, so don't look at YouTube for the questions, because now timing is important. You have to be fast, and YouTube has a few seconds of delay. So don't look at YouTube, but look at your other tab or your phone for the questions, because you want to be fast in answering. Yeah, that's a question that we get now and then. And
oh yeah, about
renaming
a column. Yeah, yeah.
Very much tricky. Okay, so I think we can start with the quiz. Maybe I can try putting some music there. You tell me if it's too loud. A bit of music. Okay. So, quiz time. There are a few questions about what we saw today, and I hope you will be able to give the right answer and fast enough to win your prizes. So, first question. Please gather all together here. Let's start with question number 1. Ready? Remember not to look at YouTube. Okay, answer fast if you want to get more points and win. Okay, so REST APIs are based on the HTTP methods and standard, or they are a remote implementation of procedure call. They offer great discoverability, or they are required after a long workshop, a bit of rest, finally. So pick your answer. What will be? And there we go. Yes, first is true, are based on the HTTP methods and standards, also called verbs, right? And loose specifications. Let's see the leaderboard. Okay, so many answered correctly, and looks like Nitesh was the fastest, but there is still some way to go, and I'll move to next question. Number 2. Answer fast to get more points. Microservices are a method to ensure tight coupling, or they are only implemented through APIs. They are a way to isolate domains and workloads and reduce coupling, or they are services for a micro company. Let's see, like a one-man company uses microservices probably. They are a way to isolate domains and workloads and reduce coupling. Sure, they are not to ensure tight coupling. Well done. Let's see.
Right. I love the micro company answer. Yes. That's awesome.
Okay, so Nitesh still keeps the top position. Manoj and Joseph follow too. Okay, there are still maybe 5 questions to go, and let's see. Which is a true statement about Apache Cassandra? That's nice. Is not highly available, or is it great for table joins and OLAP queries? It allows for geographic distribution. It runs only on AWS. So this was subject for a previous week, but we went through it fair enough, and it is correct. Most of you were correct. Apache Cassandra allows a database to be spread geographically over several locations, a single database. And for sure, it doesn't run only on AWS. It is actually agnostic.
You can run it wherever you want.
Yeah, you can run also on a Raspberry. At least you used to, maybe. Yeah.
That's right, on a Raspberry Pi.
Yeah. Okay, so Kevin was the fastest, but Nitesh keeps the position, and let's see how it goes. Question number 4. Answer fast. What were the frameworks used today in the hands-on? Micronaut and Django, or maybe Quarkus and Flask, or Spring and FastAPI, or maybe Coffee, Chainsaw, and Screwdriver. Coffee, Chainsaw, Screwdriver.
Yeah, that one sounds fun.
Yeah, I wonder if Chainsaw is something you drink. That would make. Okay, so Spring and FastAPI. That was it.
Hey, all right. Everyone was paying attention on that one.
Yeah. So we were mostly on FastAPI, but we also mentioned Spring, and looks like Kuzak jumps to first position. Josip and Nitesh follow, but still everything can happen. So well done, everyone. Answer fast for question about ACID. Do ACID requirements fit microservice architecture? Not really. Distributed isolated architecture is better fit for base. Or yes, microservices perfectly support ACID. Or yes, if support ACID configuration is explicitly enabled. No, microservices are alkaline. Do you say alkaline or alkaline?
I think alkaline sounds
Alkaline.
right.
Okay. That was hard. Not really. So ACID is too strong requirement on how the various parts of the database have to speak to each other, so to speak. I mean, it's more complex than that, but that's the gist. So the answer is not really. And let's see what happens to the leaderboard after these. Seems that that was a big overhaul, but Nitesh jumps back. Kuza and Joseph first, second, and third. Now.
You're a pretty tight race here,
6, yeah. It's a tight race. Okay, which is not an advantage of CQL prepared statements? Avoid extra trips for result set metadata, or prevent CQL injections, or validates bind variable types on the client side, or partition key based statements compute their own cluster routing. So one is not an advantage. All the other
I think we talked about all of these except one.
Yes, well done. So 6 of you got it right. So there's nothing about SQL injection protection in prepared statements.
Yeah, that's actually a benefit of using prepared statements in the relational world. But yeah, CQL doesn't allow that anyway.
And
so.
Oh, surprise! Laura jumps to first position.
Laura! Wow.
Wow.
That's
but
awesome.
It's really a handful of points. So, this is something. Okay, it is a handful of points. So let's see what happens with the last question. Be concentrated and answer fast. To connect to AstraDB, what is needed by the drivers? One IP address from the cluster, all IP addresses from the cluster, or maybe secure bundle and token credentials, or a bunch of phone numbers. To connect to AstraDB, mind that. Let's see what the answer is. Time's up. Secure bundle and token credentials. Yeah, the first would be more or less correct if we were speaking Cassandra, but this is AstraDB, and there's a special layer to introduce the proper routing and credentials and secrets for authentication. So, finally, surprisingly, Laura wins, followed by Josip and Nitesh. So, very important, before we leave this screen.
Good job, Laura, that's awesome.
Before we leave this screen, Laura, Josip, and Nitesh, please grab a screenshot of your winning screen and store it, because later you will be asked to upload it to claim your prize, because you won a prize, a bit of DataStax swag. I'm not closing the screen yet, so you have time to take your screenshot. but in a little time I will make it into a screen for feedback of any kind from you. So take your screenshot, and in the meantime, Aaron, I will go back to your slide for the conclusion.
All right. You know, I just have to give a quick shout out to Corrine, my wife, who I can tell by her text messages has stayed on through the entire workshop, and wow. I have to. I'm so impressed with her for that. So, honey, I love you if you're out there. So, anyway.
Thank you for staying with us.
So yeah, I have the screen up for the swag winners. You know, make sure that you take a screenshot of Menti and then fill out the form. Right, Stefano? They have to fill out the form that's here. Yes, is that it?
The form is now visible in the video and also on the YouTube chat. So there's a form to fill. We just ask you for address and a screenshot of your winning screen, of course, and then we will reach you with how to get your prize.
Yep, get a swag package. So there you go.
Yeah.
All right. So hey, homework. You know, if you you do the exclamation point homework in the chat, it should give you a link to go to the homework form, which is really just you know, a couple of like theory questions. And additionally, you know, our homework is to have you you know, enrich the API by adding a new endpoint for question 1. You know, of like get all networks. So yeah. So follow the instructions on that and submit in the form, and you should get your badge. All right. Hey, just in general, if you're working with Cassandra or ASTRA and you want to get help on something, these are just some resources that we have available. You know, we have our own Discord server that we've obviously talked about quite a bit. Stack Overflow.
Today we are locked out, but that's just unlucky.
Yeah, even though Stefano's locked out of it today.
Yeah. Sorry about that.
No, that's okay. I was just going to say Stack Overflow, if you have like a development-based Cassandra question, is really good, especially in the Cassandra tag. DBA Stack Exchange, which is really, you know, Stack Overflow for databases, essentially. That Cassandra tag is more for if you're running your own cluster and you're having a problem with, like, you know, a node that won't start, or, you know, something else that's goofy in terms of like actually running your cluster. That's where those questions go. But yeah, don't be afraid to follow those tags on both of those sites. It really does help the community out. Yeah, and of course, you know, we talked a lot about Discord, but you know, this is a quick shot of it. We have a workshop chat channel in there, as well as many others, you know, for you know, getting help specifically with like Cassandra or ASTRA development, or even some of our like Pulsar and like other streaming services. You can get help out there as well. So yeah. Oh, and of course, you know, don't forget ASTRA Day San Francisco is coming up at the end of August 24th. So yeah, we'll be having some talks out there, and you know, is an in-person event. So yeah, if you're out in the Bay Area, definitely check this out.
Yeah, I live on the other side of the world, but I've been told it's a very nice location. So if you are in the region, give it a thought, especially if you're eager to go back to in-person events. That's a cozy, friendly, small event to get you started.
For sure.
So
it's
going to be fun, and it's all about ASTRA. Yeah.
All right. Otherwise, hey, if you haven't, please you know, like this video and subscribe on our YouTube channel. That way you'll get notifications of you know, like other videos coming up. And yeah, I think this is really about it, huh, Stefano?
Yeah, I would say so. And yeah, what is left to say? Thank you guys for being with us. I hope it's been fun, and of course you've learned a lot. Don't forget to subscribe and come back next time, because we have a lot of workshops for you. So from my side, I thank you and wish you a good evening, morning, afternoon, whatever.
All right. Hey, thank you, everyone.
Bye-bye.
Bye-bye.
And as always, don't forget to click that subscribe button and ring that bell to get notifications for all of our future upcoming workshops.
Bien. gifted with powers from the goddess of Cassandra, who grew those powers until she could multiply at will, move with limitless speed, and unmask hidden knowledge. With those powers, she was able to fully understand the connectedness of the world. What she saw was a world in need of understanding. From that day forward, she sought to bestow her powers on all who came into contact with her, empowering them to achieve wondrous feats.